Hi everyone. In this video we're going to continue on with section 3.3, which is properties of functions. Last time we talked about the evenness or oddness of a function. This time I'm talking about if a function is increasing, decreasing, or constant. Okay, and so I think we all have a decent idea of what the words increasing, decreasing, and constant mean. I'm going to offer up here some really technical definitions, but don't let that scare you. Okay, it's just for completeness, so to speak, on my end. Okay, you can continue believing what you believe about increasing, decreasing, or constant. Now, so let's get to the technical definitions. A function is increasing on, and this is where it gets interesting, on an open interval I, if for any choices of x1 and x2 in that open interval, with x1 being less than x2, we have that the function at x1 is less than the function at x2. Okay, so that's the first one. The second definition is a function f is decreasing on an open interval I, if for any choices of x1 and x2 in I, with x1 being less than x2, we have that the function at x1 is greater than the function at x2. Okay? A function is constant in an open interval I if for all choices of x in that interval, the values of the function f of x are equal. Okay? Again, very technical definitions. Okay, and they're there for a reason, because there are some weird cases. But increasing, decreasing, and constant, hopefully what you sort of have an intuitive definition of in your head. Okay, so let's look at an example. I think that'll be the easiest for us to try to understand. Okay, so sorry. Now we're back. Increasing I'll give my own definition here. Increasing as we go left to right, okay, this way, as we go left to right, the values of the function, and what that means are the y values, get larger. Sorry for my terrible handwriting. Okay, so we want to give, so what I'm asking in these types of problems are for a given function that you see here, the graph of one at least, I want you to give me the intervals where the function is increasing, decreasing, and is constant. Okay, so we'll start off at the far left at -6, 0. So we're going to start off right here. Okay, and as we go along this function, okay, going from -6 right, we see that the values, so that's increasing, increasing, decreasing is the same, it's like ditto as the top, but the values are getting smaller as you go from left to right, okay? And then, of course, constant is the same, ditto, of as we go left to right, the values of the function stay the same. All right? So as we go left to right from -6 down to, say, -4, this way, the values of the function are getting smaller. Yes, or they are less and less and less. So we start at 0, but when we go down to -4, now we're down to -2. Okay, in the y's. Okay, so we go from 0 to -2. So in that interval, from -6 to to negative 4, I'm decreasing. And so what I'm going to put here is a bracket, negative 6, and then 2 negative 4, okay, so with a comma in between, and then I'm going to put an open parenthesis. Now that matters. A closed parenthesis, or a bracket, represents that 6 is in the interval that you're looking at. Okay, so 6 is a point where it starts to decrease. But then when I get down to negative 4, down here, it changes. We change from decreasing to what it looks like to be increasing. So at 4, it's neither decreasing nor increasing, nor is it really constant. Okay, so that's an interesting point that you'll learn a lot about later. But for right now, it isn't included in the decreasing case. Okay? All right, so at negative 4, all the way up to 0 up here, it looks like it's increasing. So I'm going to put negative 4 to 0, both open intervals, okay, or both open brackets. And that has to get back to the open interval in the weird definitions that we saw before. Okay, so from negative 4 to negative 0, it's increasing. Then from 0 to 3, then it looks, as we're going this way, constant. So open parentheses, or parentheses, 0 to 3, it's constant. Okay, and then from 3 down to 6, it's again decreasing. So 3 to 6, we're decreasing. Okay, and again at the end, 3 to 6, you can put a bracket there, okay, because we've reached the end, but it looks like we're still decreasing at 6, although it is an end point and a beginning point. So really you could be safe. Something like MyLabs Plus might want you to put parentheses there. So just be careful. I personally want you to put brackets, okay? But if they want you to put parentheses there, don't sweat it. So that's increasing, decreasing, and constant. Hopefully what you thought of before. So now let's move quickly to local max and min points. Okay, so these are also properties of a function. So a function, again, these are going to be technical definitions, but we're going to work with sort of the stuff that we know. F is a function defined on some interval. Okay, great. Okay, it needs to be a function, yes, and it needs to. We need to work with some different x's so that we can see the y's, and so that's what it means by some interval. A function has local maximas, or a local maximum at some point C. Okay, some point C in the domain. If there's an open interval in I containing C, so that for all x in the open interval we have that f of x is less than or equal to f of c. Okay, a function has a local minimum. It's the same thing, okay, but now f of c is lower than or less than or equal to f of x at every point. Okay, again, too complicated for us at the moment. Let's look at two different functions here. Okay, so we're looking for some minimum point and some maximum point on the graph, and there can be more than one. Okay, so if I look up here at this first graph on some open interval, okay, and that means maybe I want to start here at like negative 0.6 and look over to, I don't know, 0.8, okay, and I look at the values, so from like here to here, and I look in the range of values, so I'm looking at the blue line in there. Is there a point that is lower than all other points? Is there some point on the blue line that's lower than all of the other ones? The answer is yes, okay? And it turns out to be at 0, 0, so right where my red dot is. So it turns out that this function has a local min at 0, 0. Okay? So local min at 0, 0. For my other function, I look again in some range there from here to here. Is there some point that maybe is higher than all other points for this function? Also, yes, there is, and it turns out to be 0, 0 again. So this one has a local max at 0, 0. Okay, so the local maxima and minima are, there has to be some point in some interval so that that point is higher than all the other points or lower than all the other points. Where the technical definition comes in is you might say, well, okay, by that definition, if I choose the open interval, which means I just choose an interval of numbers, maybe from -1 to like -0.2, okay, and I look at this interval right there that I'm coloring in, okay. You might say, well, at -0.2, this point right there in green is lower than all the other points. And that's true, but what the wording open interval does is it says it can't be one of the endpoints. Okay, when I draw my interval, it can't be one of the endpoints. It has to be some interior point. Okay, so it would have to be like in here somewhere. So hopefully that makes a little bit of sense. It's not necessarily crucial for this, but it certainly helps if you understand in that way. Now, here's another your term. Okay, I want you to find the local maxima and minima of this function. Okay, and I want you to determine where the function is increasing, decreasing, and maybe constant. Okay, so the hint here, I'll put a hint, that there are two local mins, one local max. Okay, so there's two mins, one max. Tell me what they are, and then tell me where the function is increasing, decreasing, and or constant. So that's the second your turn.